Welcome to Allison Transmission and the Allison Plant Tour, featuring our Indianapolis, Indiana facilities. A sprawling, lively, and interconnected workplace, the Allison campus is rarely quiet. Right here at our global headquarters, we engineer and manufacture nearly all of our propulsion solutions, including on-highway products from the 1000 to 4000 series, off-highway transmissions, electric hybrid systems for transit, and defense solutions for both tracked and wheeled vehicles. Join us as we take you on a tour and discover how Allison creates the quality, reliability, and durability we're known for, from the beginning of the line to the end. At Allison, safety is of the utmost importance. We strictly adhere to the latest ISO standards, and from step 1, Allison employees follow safety guidelines through a series of orders and checks. These built-in processes keep employees safe and the work running smoothly. Leading today's tour will be Blair Ross.
Hi, my name is Blair Ross. I'm an assembly manufacturing engineer. Been here at Allison for 42 years, starting as a co-op student. We're going to take you on a tour of Plant 6 assembly line, so let's get started.
First manufactured in 1990, the 3000 series transmission was created for a wide range of medium-duty applications, and today is featured in vocations such as agriculture, pickup and delivery, emergency, transit, and more. Each assembly begins when an employee assigns a customer-specific nameplate to the transmission, making sure each unit is built to exact specifications. Since every transmission can be unique, the nameplate and associated barcode label quickly tell employees what happens next after the unit leaves their station. Allison works to control quality and consistency at every step of the process. Here, we're preparing the main transmission case for assembly and the parts that will soon be added.
This is where we can build any number of units throughout the day. If we're building 203 on day shift, we can build 203 unique units. Or we can build 203 of the same thing. We're out here in the main case department, where the heart of the transmission begins. This main case is started down in Walker, where it was cast poured.
In 2019, Allison acquired Walker Die Casting to manufacture our transmission housings. This acquisition allows for more control and further guarantees all our transmissions are quality assured and up to Allison's exacting standards. During the main case fabrication process, we mill the case and drill and tap bolt holes for the fluid filter cover inserts. The inserts are then installed to the transmission's main case. This process increases the durability of the product, allowing technicians to perform scheduled preventative maintenance on the filters without concern of damaging the threads within the bolt holes. This casing is now heading to mainline 10 to begin the assembly process.
So everything along this line is sub-assembled and fed right into the line. So from here is the very beginning. From here to the end, a couple hours down the line, we'll have the next customer's order ready to go.
Each station along the assembly line, also called the main line, is numbered so that the unit can be tracked throughout the process. Now, let's get started with the first sub-assembly.
What you're looking at right here is our brand new C3, C4 subassembly. This will actually push and turn our pistons.
The C3 and C4 clutch pack subassemblies take us to the heart of the transmission. From there, we build outward. These specific housings are where pistons are inserted and where friction clutch packs and steel plates come together. Throughout the subassembly, we perform multiple quality tests to ensure everything is up to Allison standards. Let's hear from Crystal.
I like how it catches the quality with the air leaks on there, because that's something with the pistons you normally can't see by eye. And by doing the air pressure test on there, it helps ensure that the part is good.
What's really unique about this right here is this has been designed such that it can take today's design and a future design that product engineering is about to release that will enhance the performance out in the field. As we travel the assembly line, we've left mainline 10 where we put the main case, the C3, C4 subassembly. We're now going up to mainline 20 where we will marry the rotating clutch subassembly with the front support subassembly.
A rotating clutch is part of the transmission that interacts with the torque converter and engages the engine, contributing to an increase in fuel efficiency. While the C3, C4 clutches are stationary, the rotating clutch actually spins.
I'm at one of our weld machines right here. This is where we take the flange and the rotating clutch hub, and we weld them together. From here, it makes its way over to final assembly into the rotating clutch subassembly line.
After the rotating clutch is welded, it is delivered to the subassembly area to be joined with the corresponding shaft. Shafts are specifically chosen for different applications.
We produce 4 different versions. We produce the output shaft, the main shaft, the ground sleeve, and the turbine shaft. Each one of those has a multitude of variations.
Allison uses 2 different turbine shafts for our transmissions. The longer turbine shafts are placed into power takeoff enabled or PTO enabled transmissions, and the shorter versions are placed into standard models. At mainline 20, we marry the rotating clutch subassembly, including the turbine shaft, with the front support subassembly, which included the ground sleeve shaft. The shafts help tie everything together within the transmission. One joins the ground sleeve and front support, the turbine shaft goes into the rotating clutch, the output shaft goes into the rear module, and the main shaft in the middle joins all 3. This will all come together later in the manufacturing process. Let's hear from Isaiah about how quality drives the process.
I take pride in making sure your parts are good, making sure that everything's at a quality standard, that we can have a great transmission in the end of everything.
Heat treating is one way we ensure product quality. This metallurgical process drastically increases the durability and reliability of components and materials. Now that the rotating clutch and front support subassemblies are complete, we continue down the assembly line where we marry these 2 parts together, closing off the input side of the main case.
Now we're coming to mainline 28 where we engage the converter housing. One of the converter housing right here is called the standard converter housing. We also have a PTO converter housing. Here you see the ground sleeve, you see the turbine shaft. They will engage over the top of those and later accept the torque converter into this.
We've mentioned standard and power takeoff or PTO equipped transmissions before, but what exactly is PTO? With applications in fields such as farming, construction, and emergency, PTO can provide power to operate a secondary mechanical function, such as outriggers, buckets, and more. Let's catch up with Blair back on the floor.
This is mainline 35. We torque the bolts to hold the converter housing to the main case. From down here, we have mainline 40. And at this station is where we engage the P1, the P2 carrier subassemblies, as well as the main shaft.
The carrier is the housing for the Planetary gear set containing critical components that ensure the whole transmission is operational and connected.
And in this area, we have 5 different P3 carriers. We have 2 different P2 and 1 P1. These will be meshed up with the pinions that we also fabricate in the shop, along with other purchased parts.
Pinions are the smallest gears in Allison's Planetary gear sets. They rotate around the shaft and play an integral part in Allison's trademark full power shifts. Pinions encircle the main and output shafts. They can help engage overdrive and move the vehicle. Pinions need to be exact in design and manufacturing as they contribute directly to ride smoothness and noise reduction in a vehicle.
And what's important about the pinion area is we have a gauging that sets up that we make sure that the teeth are matched up in a manner that there's very little backlash. That's very important for the noise that you hear within the transmission as it's shifting from gear to gear. And these pinions here are matched up such that they send them down into chutes, and when we get to assembly, we marry them up so they're matched. And that's important for, let's say, a touring bus that's overlooking the Grand Canyon. They don't want to hear the noise, the background noise of the transmission. So this is a very critical core part of our transmission and our design, the pinion gears.
I make sure that all my parts are good quality parts. I like to make sure everything's on the mean, right where it should be.
The final piece of this subassembly is the ring gear. Ring gears start as raw stock before the interior teeth are machined, followed by the gearing on the outside. The machined ring gear is hardened through the Nitrex process before rejoining the line.
Behind me is one of our Nitrex tanks. And this is what we do to improve our durability of things like our steel materials, in this case, ring gears.
When the Planetary gears, clutch packs, and shafts come together, the transmission can move in a controlled, efficient manner with better performance and uninterrupted shifting thanks to the torque converter. Continuing down the line, we move on to mainline 50. Here we bring together optional transmission features, including standard and retarder rear modules, parking brake adaptation rear modules, and resistance speed sensors, allowing for a truly custom build depending on duty cycle.
Very important to get it right here. And each step, even prior to when it comes here, It's verifying along the way to make sure that we get the right part. Everybody here takes pride in their job, and I can tell that people actually care about the finished product.
After mainline 50, the rear half of the transmission is enclosed.
Now we're coming to where we load the torque converter. This is mainline 70 at this particular station, and after it's loaded, we're here at mainline 75. Mainline 75 is where the torque converter is installed directly to the turbine shaft with a bolt and a spacer.
Allison's patented torque converter is what separates us from the competition. Allison's state-of-the-art torque converter multiplies engine torque to significantly improve startability, drivability, and overall productivity. With Allison's continuous power technology, vehicles don't experience the typically slower response time to throttle cycles seen with manuals or automated manuals. In short, the torque converter provides superior launch, better acceleration, less maintenance, and easier operation. Here's how it all comes together. First, the piston and damper are installed into the flywheel cover and checked for leaks. A backing plate is added and secured. 30 bolts over 6 spindles keep the assembly in place. Next, the turbine is inserted, as well as the stator and pump combination. Allison can uniquely tailor the product by varying 5 pumps and 3 stators per customer need. 3 dozen nuts are torqued into place to close the torque converter before it is leak checked a final time at this station. A barcode is etched into the assembly and the unit is labeled.
The final product here is moved from this area over to a sequencing line that feeds directly into the main line. From here, we actually have 8 different versions that we can provide for customer needs.
Well, we've got a barcode on them. The computer knows what sequence it should be in, so it'll only accept the one that it needs to have. If the wrong one's up there, we'll know it and we'll switch it out.
When we work together, it just makes our jobs easier. Quality is what I take the most pride in.
That teamwork is evident in our approach to valves and valve bodies.
The valves going into the valve bodies are very, very critical into the overall performance of the transmission. It's the brains of the shifting, the shift quality, that's very important to the customer and how we transfer them from point A to point B.
There are multiple valve body options which are installed into 3 unique channel plate housings, featuring a shallow, intermediate, and deep channel plate. While internally similar, they serve different functions. In the intermediate version, for example, we can build a front or rear cooler port.
We have the main valve body here, valves that we machine out in the shop. We're going to assemble these components here and also over here. There's a lot of different individual parts in one valve body. We have springs, valves, clips, stops.
Valves are critical to a transmission's performance. As valves move within the body, oil is channeled throughout the assembly. When a valve is engaged in a specific manner, this flow is blocked, channeling fluid in other directions, creating a smooth, seamless shift. This station also acts as a verification test. If we catch an issue here, we can fix it without having to completely tear down the transmission.
Since we keep our tolerances within those parameters, we're going to guarantee that the customer is going to get a better quality product overall through the life of the transmission.
Allison often utilizes a code scan system to track and improve component quality at every step. This system is part of our commitment to continuous improvement, and it allows us to track performance metrics and manage inventory.
By using the new barcode system, we're able to track parts more accurately through the system and also through the inspection. We can track quality data on this specific part.
Let's take a closer look at valve bodies. These intricate, maze-like parts contain valves, stops, springs, solenoids, and passageways that divert transmission fluid to the proper places in order to change gears. Certain transmissions, such as our off-highway series, have a higher proliferation of valve body configurations.
We have 47 different valve bodies, so our proliferation is very high compared to other plants that may only have 1 or 2 valve bodies that they would build.
With so many different valve bodies and components built into our transmissions, it's crucial that we get the right combination in every unit, every time. To aid the build process, Allison uses a light-guided system created to identify the right part and right sequence of selection. The light system provides a fail-safe operation, allowing the employee to efficiently select the right component for the job.
We've had this system in place for almost 2 years now, 10 operators, and had 0 quality issues. This is another great new technology coming into Allison transmission so that Allison can stand up to the Allison brand promise for all of its customers.
Every station it goes through, you're checking something that the last station has done. In other words, your coworkers have your back.
We've just left mainline 80 where we installed the control module. Now we're heading our way towards mainline 83 and 84. Mainline 83 is where we put the filters in. And a very important part of the filters is what we saw in the main case department, where we put inserts in the main case. And those filters are a very important part of the performance of the transmission. They're supposed to be changed on a regular basis, just like your car automobile filters. We're now at mainline 84. A 32 spindle nut runner is going to run these bolts in that hold the control module subassembly into the main case. This is something we added years ago. This added a lot of throughput and quality improvements. Mainline 87, this is an auto rotate station. This is an example of continuous improvements we make on the line. This basically helped from ergonomics and a throughput standpoint.
Another example of continuous process improvement is visual plant management. VPM is one of the many tools the plant operations team uses to optimize throughput and quality assurance, in addition to maintaining production schedules.
Okay, the area behind me along this wall is a visual line balance area and also a visual plant management area. Both these are key to helping us get our throughput and our quality done in an effective manner each day. The board up in the air, that will give audible signals throughout the day. How we're doing counts, numbers, also if we need support, we need an electrician, machine repairman, a supervisor. That gets immediate response. We can keep the line up and running. Down below, you'll see charts there that dictate our different line rates depending on what our customer needs are, how we do on one shift to another shift. That also takes into account things like ergonomics. We can allow to put the job split so that we are protecting the operators for their long-term health.
Going back to the assembly line, we're now moving into the home stretch, with the beginning of our final test process.
It's going to be running through shifting, it's going to be running through torques, it's going to run through stalls, it's going to run through brakes. Everything that we would want to verify in about a 4-minute cycle that the customer will see out in the field. So this is one of our first-time quality metrics that we are doing on a daily basis. 100% of the units must go through there and 100% of the units must pass. And right now we're standing in front of our final test stand. This is one of the metrics that we look at on a daily basis that makes up our first-time quality.
There are 4 reasons why a transmission may be pulled from the line for further evaluation. First, we look at line rejects. Any operator along the line can reject anything they want for any reason. During the final test, we run the transmission through a full duty cycle. If anything doesn't work right, it doesn't pass our metrics. It will go to rework for a teardown and repair. A leak decay test allows us to determine the transmission is sealed and leak-free. If further testing is required, the transmission is submerged in the dip tank where issues are identified before the transmission is moved to rework.
You know, when I took this job, I came here for the reputation of Allison Transmission. Making sure that that is our focus is everything.
The 4th check during first-time quality is CARE. At Allison, CARE stands for Customer Acceptance Review Evaluation. That's where customer labels are applied and the transmission is double-checked against the original spec, ensuring the transmission being shipped is precisely the transmission ordered. These 4 metrics are measured on a daily basis and apply to every transmission we manufacture. Nothing leaves the doors without a final check. Ultimately, the Allison brand promise ensures that everything we ship is of the best quality for our customers.
I'm the final step of the whole journey. If I don't like it, I know the customer's not going to like it.
From here, the nearly completed transmission will move on to one of 3 places: the shipping docks, the mod center, or the audit teardown crib for reliability testing. Some units require unique customer-specified parts, such as a cooling unit. This work takes place at the mod center.
From here, the operator is going to manually put it on a heister, travel it around, do a number of steps, and modify the unit to meet the final customer's needs.
To further ensure quality, completed transmissions are periodically pulled and torn down, step by step, by reliability auditors who double-check every aspect of the transmission build. Here is Randy, a reliability auditor, to elaborate.
We take a random unit off the line. We'll take it back. One of our auditors will disassemble it completely. We'll measure for tolerances, basically assure that the assembly process is being followed. After the audit, we reassemble the unit and we feel like they're getting the best transmission they can possibly get.
Finally, the transmission is ready to ship. Here's Kurt to explain the last steps before sending each transmission out into the field.
On a daily basis, we would typically ship somewhere between 600 and 900 transmissions. We scan every unit that goes out. So we scan the shipping label, and then we scan an additional label called the WIP label to confirm that those two match and that we're sending the right transmission to our customer.
Thank you for joining us on the Allison Plant Tour. We look forward to your continued partnership and interest as we continue to improve the way the world works. As James Allison said when creating Allison Transmission, whatever leaves this shop over my name must be the finest work possible. We are still driven by this philosophy, and you'll experience it in everything we do.